classes, both at high school and university level. So in today's class or today's discussion, we have got a question of mole. We are told how many maple chips, that is calcium carbonate, remains undissolved, and what volume of carbon 4 oxide at RTB formed when all 14.6 grams of hydrochloric acid are allowed to react with 50 grams of maple chips. So this question is asking two things here. You were told how many maple chips, that is calcium carbonate, remains undissolved. That is one question, part one of the question. And part two is saying what volume of CO2 gas at RTB formed when 14.6 grams of HCl is reacted with 50 grams of calcium carbonate. So in this question, the first thing we will do, we will write balanced chemical equation, a balanced chemical equation. So let us write that. We have got the solution here. So that is calcium carbonate plus hydrochloric acid forms calcium chloride, carbon 4 oxide, and water. So is the question balanced? The question is not balanced. We need to place 2 there to balance the equation. Solid, aqueous, gas, and liquid. So that is our balanced chemical equation. Okay, again, the second thing we do is we use what we have to solve what we don't have. So in this, we have got 14.6 grams of HCl, that's hydrochloric acid, is reacted with 50 grams of the carbonate, that is calcium carbonate. So first we need to get the number of moles of hydrochloric acid. So number of moles of HCl, number of moles of HCl, that's hydrochloric acid, is equal to, since we're given the mass and we know the molar mass, so the number of moles equals to what? Mass all over the molar mass. So the mass of the acid is 14.6 grams, 14.6 grams over the molar mass of hydrochloric acid. For hydrogen is 1 and chlorine is 36.5. So I mean that 5.5. So add them, so that will give you that 6.5. So divide that 6.5. That will be 14.6 divided with 36.5. So that will be 0.4 moles. 0.4 moles. So that is the number of moles of hydrochloric acid. Okay, and then, so to solve now the first part of the question, that is the number of calcium carbonate that remain undissolved, or the amount of calcium carbonate that remain undissolved, we use the mole ratio to get the number of moles of calcium carbonate. So here we have got the mole ratio is 1 to the ratio 2. The mole ratio of the carbonate and the acid is 1 to 2. So that is, the mole ratio is 1 to the ratio 2. That of carbon 4 oxide is also 1. Okay. So to get now the number of moles of calcium carbonate, let us use this and the mole ratio. Since we know the number of moles of hydrochloric acid is 0.4 moles, So that will say if 2 is equal to 0.4 moles, what about 1? So that will be 1 times 0.4, 1 times 0.4 all over 2. So that will give us 0.2 moles. So the number of moles of calcium carbonate is 0.2 moles. We have got that 0.2 moles by using the mole ratio. Okay, now, since we have got now the number of moles of calcium carbonate, we can get the mass of the calcium carbonate that has reacted with the acid. So mass of the calcium carbonate that has reacted is equal to number of moles times molar mass. So the number of moles of calcium carbonate is 0.2 times the molar mass of calcium carbonate. Calcium is 40, and then carbon is 12, and then oxygen is what? Oxygen is 16 times 3. So 16 times 3, this is now 40 plus 12, that is 52, plus 48, that will give us what? 100. So the molar mass of calcium carbonate is 100 grams. So to get now the mass is the number of moles times molar mass. So times 100 grams is equal to, let's multiply that, 0.2 times 100. So that will give us 20 grams. So that means 20 grams of the maple sheep, that is calcium carbonate, has reacted with the HCl, with the acid. So, and the mass of the calcium carbonate that was initially used was 50 grams. If the mass of calcium carbonate that was initially used is 50 grams, and the mass that is reacted is 20, so the mass of calcium carbonate, the mass of calcium carbonate that has not reacted, the mass of unreacted calcium carbonate will be 50, the initial mass, minus the mass that has reacted, that is 20. So that will give us what? 30 grams. So that is the mass of the marble chips that remains undissolved. So that is the first part of the question. Again, the second part of the question was asking what volume of carbon 4 oxide at RTB formed when this mass of the acid has reacted with the marble chip. So again, we will use the mole ratio to get the number of mole of carbon 4 oxide. Since the mole ratio of between the acid and the CO2 gas is 2:1, we can get the number of moles of carbon 4 oxide by using the mole ratio. So that means the mole of HCl, CO2 gas, moles of CO2 gas, number of moles of CO2 gas will be by using the mole ratio will be 0.4 times 1 over 2, which is 0.2 moles. So that is the number of moles of carbon 4 oxide using the mole ratio. So to get now the volume of CO2 gas at RTB, it is very easy, because we'll say 1 mole of a gas at RTB occupies 24.0 dm cube. So we'll only find what about 0.2 moles of carbon 4 oxide gas. So we'll say if 1 mole of carbon 4 oxide occupies at 24.0 dm cube, what about 0.2 moles of the CO2 gas? Okay, so that will be 0.2 moles times 24 dm cube all over 1 mole. So that will give us 0.2 times 24. That is 4.8 dm cube. 4.8 dm cube. So that is the volume of carbon 4 oxide at RTB. And that is how we do that question. Thank you for watching. Please subscribe to the channel to get more.